Hi guys, today I'm going to be explaining to you how I worked out exam 2 question 3. I'm not going to rewrite everything just because this would take a lot more than 3 minutes. So I'm just going to kind of work through everything and explain to you how I got. So today the question is asking for the distance, or how far up, or the displacement, how far up the incline will the block slide. And we're going to be solving by using this formula, which is the work plus the kinetic energy, the initial kinetic energy plus the initial potential energy is equal to the potential energy, the final potential energy, the final kinetic energy plus the heat loss during this whole, like the whole work done. And so for our example, we had no initial work after the spring was let go of. So we can account that to 0. And then the kinetic energy, there's no movement after the block is let go. So we say there is no initial kinetic energy. There's only initial potential energy, which is stored from the spring. And then that's going to be equal to the final potential energy plus the final kinetic energy. But we don't have any final kinetic energy because it's not moving after that. And then the heat lost during the, like, going up that incline. And I drew it. This is the horizontal plane, and this is the spring, the block. And then remember, we're going up an incline and we're asking what's the distance traveled, or the displacement. So now we're going to set it up. So we're going to set up 1/2, which is the constant, which is this right here. K equals 1200 newtons per meters. And then we're going to do X, which is the distance while the spring was compressed. And then that's going to be squared. And that's the 0.3, by the way, wherever that is. Let's see, the 0.3, but we're going to convert this from centimeters to meters. And then that's going to be set equal to the mass times the gravity times the height plus the final frictional force, or the frictional force, I'm sorry, plus the displacement. And then we're going to solve that by solving for the D, which is, so how do we get the height? To get the height, we have to sub in distance sine of the angle, which the angle is 30 degrees, remember guys, right here. And that's the angle that's here. Like, so like, say that's what the angle is, and that's how we're going to be able to solve for it. So then I just plugged in my numbers. So we had 1/2 times K, the constant, times X, which is the displacement, or the how much it traveled. Then we're subtracting the, and we're doing that squared, by the way, don't forget the square. Oops. And then we're subtracting that from the mass, which is 20 kilograms, the gravity, which is 9.8 meters per second squared, which is just a constant. And then we're doing that times the mule, which was a given in the equation. And then we're doing that by times 5. And then we're dividing this all by 20, which is the mass again, times 9.8, which is the gravity, and then sine of 30, which is obviously the cosine. The sine. And then from plugging this all into my calculator, oopsies, I got D equals negative 0.163. And then if we were going to solve for big D in the equation, which is what the guy from the video did, we're just going to plug in the same numbers, but we're going to use this equation, which is 1/2 times kx squared equals mg mule d. And we're just going to set up the equation to solve for d, and that would just look like 1/2 times 1200, which is the constant, times 0.3 squared, which is the x, which is the distance. Then we have the mass, the gravity, and the mule. And that gives us 1.3776 meters. That is my explanation for question 3 of exam 2. Thanks for watching.